All right, so we're going to continue then on page 11 with the notes. So we're gonna start, why am I struggling? So we've already completed everything there was for divergent. Now we're gonna start with convergent plate boundaries, which I believe you already at least wrote that part, where convergent is where two plates come together. If you haven't already written that at the top, that goes in the top middle section. So we're going to be talking about when two plates converge or when they come together. There's actually a couple different things that can happen. The first thing is if a continent hits a continent. That's going to cause the crust to be pushed upwards. Both plates are going to end up going upward. This is how we get mountain ranges. So whenever I've asked you guys about plate tectonics, I asked you what the plates can do. Almost every single time you guys take your hands, put them together and make a mountain. So this is the obvious, two plates come together and they make a mountain range. This is what's happening in the Himalayan mountains where India is slamming into Asia. So India is a continental crust. Asia is a continental crust. When they come together, both plates end up pushing upward and they make these giant mountain ranges. The Appalachian Mountains are also caused by when two continents came together. So I just want to talk about this a little bit. So the Appalachian Mountains are found here along the east coast of the United States. So I've drawn a picture of them up on the board. Oh, they're right here. So here's the Appalachian Mountains. I just said they happened when two continents slammed together and both continental plates went upwards. Well, what's missing from that map then? There's a new boundary there. So there's no other continent slamming into North America presently. So then how did those mountains get there? There was another plate. I see in the background doing your charades. I know what you mean. So there used to be another plate here. There was a whole nother plate that slammed into the east coast of the United States. This is actually in a reference table we haven't learned yet, but I can tell you, I'm not going to make you go there yet. It's 2 chapters from now. This happened around 470 million years ago. A whole nother plate slammed into North America, and that plate is now gone. It's all, that plate squished all the way up and is now in those Adirondack or Appalachian Mountains. The same is going to happen here to India. What's eventually going to happen to India? Where's it going to go? It's confused. What did you say? Oh, I'm pulling down my mask to hear you. Yeah, all of India is going to squish up and become the Himalayan mountains. So eventually India is going to completely be the Himalayan mountains. I wouldn't want to live there when that happens, but good news is it only happens as fast as your fingernails grow. All right. So we already said that. So now sometimes when plates hit, they don't both go up. What happens is sometimes one goes down, and that's called a subduction boundary, where one plate goes under another. On the reference table, they show which one is going under the other. So on the key for convergent plate boundaries, they label the overriding. So overriding means one going over with this line with the boxes on it. So the side that has the boxes is the one that's going over the other, and the empty side is the one that's going under. So for example, here in the Peru-Chile Trench, the South American plate is the one on top, and then the Nausicaa plate is going underneath that one. So this does not happen randomly. It does happen when an ocean plate hits a continental plate. The ocean plate will always go under the continental plate. This will always create this deep sea, trench. So a trench is basically like a big ditch. So as that plate goes under, it kind of creates a ditch, that V shape next to the continent there. So we'll always have these deep sea trenches, and it will be bordered by a mountain range on the continent. This is again happening here at the Peru-Chile Trench. So we have a trench forming along the west coast of South America. And then we also have the Andes Mountains on South America. And then the last subduction zone happens when two ocean plates hit each other. Again, one will end up going underneath the other. So this is actually how Japan has formed. Japan formed as two ocean plates collided and created a volcanic island arc. So Japan is very similar in the idea that it was just a volcano that erupted when two ocean plates came together. All right, we're just about done here. I believe we already got, yeah. Yep. Sorry, I went back one slide. So all right, you got this or not yet? You're good? Okay, and then here's the ocean plate in case some of you did not finish that. Good, everybody? All right. Then the last kind of boundary is the transform plate boundary, which I think we already took the notes for. This is when two plates slide past each other. This next slide, you don't have to take the notes. I just wanted to talk about it a little bit. So we may have already talked about this. I can't quite remember. So the San Andreas Fault does not actually cut all of California off. It's just this little thin section here on the west coast. This does cause major earthquakes. And really what happens is those plates are trying to slide past each other. It's not every single day they move. What's happening is every single day they try to move, but they can't move every day because they're kind of like stuck on each other. And all of a sudden, one day, after enough pushing and shoving, they kind of make a major jump. And you will actually be left with major changes in the way the ground looks after one of these earthquakes. All right, Alfred Wegener. So that's the different kinds of plate movements. So he didn't know all of this stuff. He was only able to talk about those few pieces of evidence we talked about this past week. So we talked about they matched up like a puzzle, that the fossils match, the rocks match, and the glaciers match. One more thing that he didn't know about are these benchmarks. If you remember back a few months ago, we talked about these benchmarks. They label the exact elevation at specific locations. When I talked about one, I talked about there was one, so we're still on page 11 there, just more evidence. We talked about there being one outside of Arcade Elementary School. This one that I have a picture of was put here. It's actually in Hawaii in 1955. They put it there with the exact elevation, the exact latitude and longitude. So that was a good, 65 years ago? 66 years ago? They can go back there now and it's not in the exact same spot. It's a little higher up. It's a little bit more northwest. It's moved. The only explanation for it moving is that the plate is moving. Another piece of evidence that Alfred Wegener did not have at his disposal was this uplift of fossils. We can find fossils of fish at the top of the Himalayan mountains. The only way a fish fossil could have gotten to the top of the mountain is no, the oceans were not that high, because the Himalayan mountains are the tallest place on earth. They're not that high. The oceans weren't that tall. What happened is the mountains used to be as low as the oceans. And then through plate tectonics, they have been pushed upwards. All right, and then the last thing for continental drift is the opposite of uplift. Fossils have also been pushed so far underground where they don't belong. The only explanation they got that far, again, is they were being pushed under as the continents came together. So the last thing we have to learn about is hot spots, and then we are done. Hot spots are exactly what they sound like. They are spots that are hot. It is a place where magma is coming up through the Earth's crust. And I have a quick video to show you for this one. I'm gonna go ahead and show that video. Let me find it. So I have two separate ones that I like. Start with this.
When advertising on YouTube, I know that making an authentic video with a clear call to action is the key to getting results. That's why YouTube offers tools, resources, and partners to help businesses of all sizes reach. Volcanoes usually occur frequently, where the continents dry.
This is actually not the one I wanted to show, but it'll work.
The Pacific Ring of Fire marks a whole series of these plate ranges. Why? 2,000 miles. Beneath the ocean floor is a mysterious area of superplot for rock. Button up to melt a hole in the Pacific plate, punching up fresh lava. It's called a plate. The ocean floor is being gradually northwest after it reaches the roof of the hot spot under that's the moon. A volcanic island builds up, but as it moves away from the hot spot, it's cut off from the source of lava and dies. Over the hot spot, a new volcano forms. But if the big island is growing, then what's happening to the island of Oahu? Oahu should be shield shaped, circular, but it's not. It's long and thick. There's a chunk of it missing. All that's left are 1,000-foot-high cliffs.
You have to tell that this is a shield volcano anymore, but the second that will lift it from the spot.
As the water turns to large soil, cracks deep. A fatal weak spot develops until one day it all just lets go. This cliff is cracked 1,000 feet deep. Based on the shape of the rock and the height of the cliff, Lloyd estimates the land is going to extend out from here for about 20 miles.
All this is exposed rock. And all that rock disappeared.
The ocean below. Two million years ago, the island fell apart. 300 square miles, 20 trillion tons of rock dumped in the Pacific Ocean. That's why rock has an unusual shape. The rocks don't really have some bite of the island.
I'm Dr.
So that was a little bit more than what we needed. What I was really looking for. Not this one again. Let's see. This one's weird, but it has the explanation of how hotspots form an island. So I need you to try and watch this one for a second.
A hotspot is a localized source of high heat energy that's the same as volcanism. It is not an isolated shallow magma reservoir beneath the crust, nor is it a pipe of magma that streams from the outer core. One theory holds that hotspots may begin as a blowtorch-like thermal perturbation in a zone between the liquid outer core and overlying.
So those of you doing your homework, make sure you pay attention to how hotspots form.
The thermal flume allows solid yet mobile land to rise very slowly and back outward. Convection is the process by which heated material rises and cooler material sinks. Although magma may be generated as deep as 1,500 kilometers. Individual blocks do not traverse the entire net. Let's zoom in to look at the onset of hotspot volcanism beneath the surface.
This is a key that I need you to pay attention to.
Melt stalls. Its heat is transferred to a base of rock. This transfer continues to the base of the tectonic plate, where decreased pressure facilitates rock melting. The magma that forms at the base of this plate rises through the plate in a network of cracks and shallow chambers and erupts on the surface.
So we have these basically underwater volcanoes that's making islands, that's starting to form an island.
Large volcanoes build on top of the plate. The weight of the volcano bends the plate down. Volcanoes that spend their constructive life over the thermal plume slowly get wrapped in a way.
So because of continental drift, the plate moves.
Multiple dikes can feed several volcanoes from separate continents.
So again, the key here is that when the volcano is over the hotspot, that's when it's going to be building an island, and it's going to get bigger and bigger and bigger as it's over the hotspot. But because of continental drift, that plate will shift, and the original island's no longer above the hotspot, so it stops growing, and new islands pop up behind it as that volcano keeps spewing its lava over and over again. So again, that moves and moves and moves, and we end up with this chain of islands. This is exactly how Hawaii was formed. If you look at the continent, one thing that video talked about was that most volcanoes are found along the Pacific Ring of Fire, which is right around the edges of this plate. That's where you'll find most volcanoes, earthquakes, mountains, trenches, etc. They're all on plate boundaries, which is exactly why up here in Buffalo, we don't have any ginormous mountains. We don't have any earthquakes or very many earthquakes. We don't have any volcanoes. We don't have any trenches or ridges. Why again do we not have any of that stuff? Because we're not on a plate boundary. All that fun stuff happens on the boundaries only, which is why it's weird. Hawaii right here in the middle of the plate, how does it have volcanoes on it? Because it's over this hot spot where they're constantly spewing out their lava. What I'd like you to do is flip over to page 14. Make sure you know how to answer questions about hot spots. This is a diagram here showing you how the island chain formed. So you have first this little picture, which is showing kind of what it looks like in the grand scheme of things. So the state of Hawaii is not just one chunk of land like New York is just one chunk. Hawaii is actually a chain of islands. It's made of 5 major islands. These islands are found right in this section at the top here. What they're showing you is the hot spot is directly underneath the current island named Hawaii. It is the biggest one. But like that video said, each one of these little islands used to be over the hot spot. And because of plate tectonics and continental drift, the plates have shifted and taken those islands with them. One thing the Regents is going to ask you to do, and I don't really like this question because they gave you the ages. So if they did not tell you how old each island was, how could you tell which one was the oldest? Exactly. So remember, the one that's on the hot spot is the one that is the youngest. It's growing currently. It's the present day active volcano. So the one furthest away is going to be the oldest. On the same note, you can tell which one's the youngest because it's the one currently above the hot spot. And then the next thing they're going to do is ask you, well, which way is this island, or which way is the plate moving? And I'd like to explain that one as kind of working backwards. You kind of have to ask yourself, okay, here's this island. Where did that island used to be? To form, where did that island have to be? Yeah, it has to be over the hotspot. So this island here used to be over here. So which way has it moved? It's gone Yeah, it's gone this way, which, sorry, I'm writing on something. So it's moving that way, which according to the key, it's not straight north, it's a little what? Which way is that? If that's north, this is south. Yep. So never eat soggy waffles. So this way is northwest. So that's kind of the questions they'll ask about Hawaii. So actually, here's another question. Question 24. Make an inference as to why Hawaii is larger than the others. There's two possible good explanations for this. Can you think of one reason Hawaii could be the bigger island? Huh? Oh, yes, that there. I like how you changed up. You just added a word. It's being formed the longest. What does that mean? Now, it's not that it's been there the longest, because that would mean the oldest. But what do you mean by been there the longest? There, it's been over the hot spot the longest. So one potential reason is the plate slowed down. If the plate slowed down, it's been sitting there longer on that one. On the same note, there could be more lava too. So the volcano could be pushing out more lava right now. There's also one other really good explanation that was kind of covered in the first video, which is why maybe these islands are smaller than Hawaii. What could make them smaller? Yes, the older islands have had time to erode. And the last concept they're going to make sure you know for this is, all right, another island's going to form in a couple million years. In this island chain, where will another island form? Yeah, at the end of the other one. So it's going to be right here behind Hawaii, because what's going to happen are all these plates are going to move this way. So a new one's going to form above the hot spot. So where is a new island forming? You could say behind or over the hot spot. Anything like that that explains it. All right, so that's going to wrap up plate tectonics for us. Like I said, you do have homework. I only got about 5 minutes left, but you can probably get a good head start if you haven't already on page 13.